Reflection of plane waves using Huygens Principle. Suppose there is a boundary on which waves are falling, that is incident wave. But Huygens language, these waves are actually wavefront. If we want to calculate the wavefront, we have to join the points having the same phase. Now, incident wavefront will be look like the following figure. Since light is coming from far away, so the line OA is a kind of plane wavefront. Now we take a surface. Incident wavefront will strike on the surface. This incident wavefront strikes the boundary of the surface. According to Huygens, wavefront is capable of producing secondary wavelets. These secondary wavelets will generate when incident wavefront strikes on the boundary of the surface. Since this is a wavefront, then it will not strike only one point, that is P1. The points will be P1, P2, P3 like this. Let the speed of the wave equal to V. P1 will come first, then P2 and P3 and so on. Let the point P1 strikes the surface at time t equal to 0. Point Pn will strike the surface after time tau. All the points not striking the surface at the same time. P1 point strikes on the surface. P2 point strikes on the surface after some time, and Pn will strike after time tau. Since velocity of wave equal to v and time taken for Pn is tau, so according to S equal to Vt, so S equal to V tau. Pn point have to travel extra V tau distance to strike the surface. All the points nearer to Pn will have to travel extra V tau distance and strike on the surface. Since AB is not an incident ray, it is a incident wavefront. All the points are on the same phase shown in the above figure. These points are nothing but the points of the entire wave. The wavefront is not striking the surface once at a time. For striking the surface by all the points of wavefront, it will take some time, one by one. All the points of the wavefront will strike the surface. As the point strikes on the surface, secondary wavelets will form. That is, small waves will be generated. These wavelets are produced like the following figure. According to Huygens, the common tangent of all the circles is the position of the wavefront after time tau. AB is the incident wavefront. CD is the position of the wavefront after time tau. CD is the reflected wavefront. In this figure, AB is the incident wavefront. Reflected wavefront is the position of wavefront after time tau, that is CE. All points on the incident wavefront will not strike on the boundary of the surface. Here time lag is tau. If the speed of wave equal to v, after time tau, reflected wavefront is the position of the incident wavefront. So Bc equal to v into tau. The points lying on the incident wavefront will have to cover extra Vt distance. When the incident wavefront strikes the boundary of the surface, then spherical wavelets are generated. The radius of the wavelets will be determined by V tau. Here, for reflection, the medium is same. Velocity of wave is same. Incident and reflection are in the same medium. The common tangent of secondary wavelets gives the reflected wavefront.